Hello everyone. In this lesson we have an introduction to percents, and by the end of the lesson we'll be solving percent problems, some basic percent problems. And percent basically means per 100. I'm going to just go through the pencil problems with you. You could read the key concepts in the example here, but essentially to change a percent to a decimal, we're just simply going to move the decimal point 2 places to the left and drop the percent symbol. So here's the given percentage, 6.3%. So I'm going to use these little loops to indicate movement of the decimal point and 2 places to the left. That little space in there requires a placeholder, and that placeholder of course is a 0. So this would be equal to, I always put a 0 before the decimal point. You don't have to. And then we'll recopy 063 and drop the percent symbol. So again, 2 places to the left and drop the percent. And then the next concept is to change a decimal to a percent. So we're going in the opposite direction. So what we're going to do is move the decimal point 2 places to the right and add the percent symbol. So if we start with 7.6, then again I'm going to use these little loops, but we're moving to the right now. So, and it's always 2 places, and the reason why it's 2 places is because percent means per 100, and 100 is 2 decimal places. So 2 decimal places to the right, add the percent symbol. Again, we see a need for a placeholder, and so let's recopy. That would be 760%. Now, just as a little trick to remember which way to move, put the letters, the first letter of each word in alphabetical order. That is decimal D, fraction F. So if we're going from a decimal to a fraction, we move to the right 2 places, like we did in this example. So we started with the decimal, moved it to, percent, not fraction. So decimal to percent, 2 places to the right, and if we're going from percent to a decimal, then we move 2 places to the left. And again, it's always 2 places. So this is just a helpful little trick to remember which way to move. Okay, next pencil problem. The key concept is writing percents as fractions. And so we can't go directly from a percent to a fraction. We first have to divide. So let's see here, if we go from a percent, we first have to write it as a fraction and then reduce it. So again, percent means per 100. So let's go to the pencil problem. Here you can see a simple example. Just write 8% is 8 over 100, drop the percent symbol, and reduce that fraction. So greatest common factor is 4. You can use your fraction calculator to reduce that if you like. So here we start with 1.4%, and we write it with the denominator of 100 and drop the percent symbol. Okay, now we see something that we saw back in lesson 1, where we have a decimal mixed with the fraction. And so we're going to have to get rid of the decimal by multiplying the numerator and the denominator by an appropriate power of 10. And since this decimal number is to the nearest 10th place, we just need to multiply by 10. So we multiply by 10 over 10. Remember, whatever you do to the numerator, you have to do the same thing to the denominator. So that gives us 14 over 1,000. And now we could reduce. And I'm going to go with a 2. Divide both by 2. And we get 7 over 500. Okay, next concept is fractions to percents. And this is what I was thinking of earlier. We can't go directly to a percent from a fraction. You start with a fraction, then you go to a decimal, and then you go to the percent. And the way to go from a fraction to a decimal is just simply to divide. And you can even use your calculator to do the division. So you can see this simple example, 3 over 8. Just type it in, 3 divided by 8, we get 0.375, that's a decimal. Change to a percent, 2 places to the right, add the percent symbol. So you can see our result there. And so to the pencil problem, 7 over 20 is a percent. Okay, so if I start with 7 over 20, do the actual division on the calculator. You can do long division if you like, but simple enough. 7 divided by 20 equals, see, 0.35. So there's a fraction to a decimal, and now to a percent. 2 places to the right. Okay, so then let me do it this way. When I use these little arrows, that means implies, or you could read it as then. But I'm not going to say equals, so I'm just going to kind of say implies and show the work. 2 places to the right, add the percent symbol, and so now it's 35%. Okay, next key concept, finding percent increase, decrease. There's a little formula here. It's just the amount of increase or decrease. So it's just sometimes what I'll call the difference. So we subtract, always divided by the original amount. Okay, so we'll jump right to the pencil problem. And then we're going to have to change that. That'll give us a decimal that we'll have to change to a percentage. And so, to the pencil problem. Okay, we've got a 500 television. It's on sale for $425. The amount of decrease and the percent of decrease. So, the amount of decrease is just the difference. And you always take the high minus the low, so we never get negative numbers. So $500 minus $425. So that gives us $75. And then the percent decrease is that difference, I'm going to say, over the original. So the difference is that result, $75, divided by the original. And so the original here, it started at 500, so you got to make sure you pick the right one. So whatever it starts at, not always the largest. Okay, so then we do the division, use a calculator. For convenience, 75 divided by 500 is 0.15, but that's a decimal that we want to change to a percent. So I won't show it literally. 2 places gives us 15, right? And add the percent symbol. So we should be able to see that. Okay. I just want to mention, if we go back to the pencil problem, or excuse me, the example that preceded this. As I said, it's not always the larger that's the original. This was a percent increase, and again, we always take the difference. So here it is, 400 minus large minus small, no matter what. And then the amount of increase was the 150, and the original amount here, notice, was the 250, because we started at 250 and it went up to 400. So you always divide by the original. They gave us 0.6 and then changed to a percent. So I just wanted to make sure we noted that. Okay, moving on. Solving basic percent problems. There's 2 ways to do it. You could use the rate, base, and part idea, which you have probably learned as, or you've heard the expression, is over of equals percent over 100. Mathematically, that's really not the best way to think of it, but it works. You always have to think of the rate as your percentage. That's the easiest one to find because it's either given or you're looking for it. And just think of the base as the whole, or the total quantity that's under consideration. A lot of times it's nice to put it in the context of like sales tax makes sense. When you're buying something, the base is going to be your purchase price. And then the sales tax that you pay is the part or the portion of that would be added to the base to get the total price that you're paying. So we have the formula, part over base equals percent over 100. So that's our rate, the percentage over 100, written over 100. So we showed an example here using this method where we identify the rate, base, and the part, and you just simply plug into the formula, and then we're used to cross multiplying from less than 1 and dividing to get our final answer. So same idea in the pencil problem. Okay, I'm going to write down the words rate, base, or part I'll go to next, be consistent with our notes, and base. So fill them in. You're going to know 2 out of 3. And the rate's always the percentage, so that's the easiest. So 2%. And I have to determine what 10 is. Is that the part or the base? Well, here's a key phrase that we're going to be using momentarily as well. The idea is that the percent of the base is the part. And that's why when I wrote earlier, the is over of equals percent over 100, the is represents the part and the of represents the base. So what follows the word is represents the part, and what follows the word of represents the base. Now you do have to be a little bit careful. That's why, as I said, this is not 100% mathematically sound, no pun intended. Because I mentioned percents and we're doing percent problems. So in any event, it says 2% of what number. So right away I know it's the what number. I'm always taking a percentage of the base. So the what number is the base, that's the unknown. I'll call it X. You can call it anything, any letter you like. And that would mean that the part is 10. So then we go to the formula. And the formula formally is part over base is, I'm going to say percent over 100. So the part is 10 over the base, the unknown, equals the percent 2 over 100. So notice how I dropped the percent symbol. That's why we got the 100 in the formula. And you just put the rate in as it is. Okay, cross multiply. 10 times 100 equals x times 2. Remember, we always want to write the coefficient first. So 2x, and no need for a multiplication symbol there. Obviously, you could have multiplied the 10 times 100 to get 1,000. And you didn't need to show that step. And then we're going to divide. And always divide by the coefficient of the variable, or as you guys probably say, the number in front of the letter. So we're going to divide by 2. So whatever we do to that side, we do to this side. And x is 500. Okay, so that's using the rate, base, and part model. And we have one more example using that as well as a pencil problem. So here the important thing is that if you're looking for the rate, I'll just quickly go through the example. If you're looking for the rate, you have to do something at the very end. And that is to make sure that you add the percent symbol. So here we're given the part and the base. And again, remember, the phrase blank percent of blank of the base is the part. So the percent of the base is the part. So that's why the 125 is the base and the 75 is the part. So we have the 75 is the part, the 125 is the base. We write x over 100, cross multiply and divide, we get 60, and so you have to make sure you add the percent symbol. So x is 60 and the rate is really 60%. That's kind of a subtle point. But the rate is always over 100. So now it's worded a little differently. Like the 11.07 is first. And it says, so I'm going to write down the words again, rate, part, base. And it says 11.07 is what percent of 135. So again, the percentage is the rate. That's always the easiest to identify. You either know it or you don't, and obviously we don't know it here, so we'll call it X. And that's where you have to think of the phrase that, again, the percent of the base is the part. So therefore I know, since it's saying what percent of 135, I know the 135 is the base. And that would mean that the 11.07, see, even though there's no is in front of it, that's why I was saying that that formula is not, the is over of thing is not always the best. We can discern that that must be the part. So again, the formula, you don't have to write it down at all times, but I'm going to do so here. Part over base equals, I'm going to say percent over 100. So the part is the 11.07 over the base, 135, equals the percent that I'm looking for, x over 100. Cross multiply. We get 1107, because 11.07 times 100, use your calculator, equals 135 times x, or 135x. Divide by the coefficient of x, so I'll show it literally. I know many of you just jump in here right at this step and divide by the 135 without showing what I'm showing in this extra step, and that's fine. So what I'm saying is, if you take it from this point, if you see 1107 equals 135x, many of you are just going to divide by 135, divide by 135, without taking the extra step to show it. But in any event, we get to the result. Okay, use your calculator. 1107 divided by 135. And we get 8.2. So remember, you have to make sure you understand that it's the rate we're solving for. So then we could say that the rate is 8.2% at the end of percent symbol. Okay, so that's the rate, base, and part method. I'd like you to consider this what we call the equation method. And with the equation method, you could read this entire page on your own. And it tells you how to translate the sentences from mathematical to, or from words to a mathematical sentence. But the whole, I'm going to use what I've been suggesting is this model right here. You could use either one, but I always like to use this model. Oh, I'm sorry, not that one. It's going to be this one, the one on the right. You can use either one, but I like this. So I'm going to say this one is preferred. this sentence here, blank percent of blank is blank. I'm going to write that down every time, and then you're going to see how to fill it in. And all you have to know is that of means to multiply. So of implies multiplication, and is means equals. So if we just start with that one sentence, blank percent of blank is blank. Fill in the numbers, which will be very easy as we'll see, and then know that of means multiply and is means equals. There's just a couple subtle things and makes the solution much easier. So we'll see that here. Here's the example. You can read that on your own. I just want to show you how simple this makes it. I'm just going to write it down. No rate base and part anymore, although we could think of it that way, and we should. But the whole idea is that the percent of the base is the part. So I'm going to write it down. Blank percent of blank is blank. And then just fill it in. It said, what is 8% of 180? Obviously 8 goes here with the percent of 180. So the 180 follows the of. That means we're looking for the is, or the part. And then the only thing you need to do is understand that when you're translating this to an equation, the percentage needs to be changed to a decimal. So remember, percent to decimal, 2 places to the left. 8% becomes 0.08. Of means multiplied by 180, and is means equals, and that's x. And then all we have to do is take 0.08 times 180. So 0.08 times 180 is 14.4. And that's going to be the part, or what we're calling x. So, much easier method, and I'd like you to try to use this method because we're going to be getting into algebra after this first unit test, or second unit test, I should say. And knowing how to solve the equations is going to be helpful. So one last example and pencil problem here. You could read through the example on your own, but it uses the same concept. And to the pencil problem, I recognize it as a percent problem, and so I'm going to write down my standard sentence. At all times, you could just say blank percent of blank is blank. Now, if you want to use the rate base and part method, that's fine, but I think this is much simpler. And again, when we get to algebra, this becomes more useful. So obviously it says what percent, so the percent's the unknown. And you don't see a percent in here, so obviously that's what we're looking for. And then look at how simply it lines things up for us. Of 180 is 36. And then just translate it. X of means multiplied by 180 equals, is means equals, of means multiplied again, is means equals, so equals 36. Okay, this x 180 I could have written as 180x, which is preferred. And then we divide. Remember, always divide by the coefficient of the variable, or as you guys say, the number in front of the letter, right? Or number in front of the x. So divide by 180. I show the extra step as I've mentioned. Okay, and then the only thing you have to make sure you do is, after you do the division, if you are solving for the percentage, so I'm just doing 36 divided by 180 on my calculator, I get 0.2. We have to make sure we change that to a decimal. So therefore, the percent that we're looking for is 0.2 changed to a decimal. Remember, 2 places to the right, and add the percent symbol. We need a placeholder, so it looks like 20%. Okay, so that's the end of lesson 2. Feel free to email me with questions or concerns. Hopefully that was helpful. And remember, these problems correlate with the questions on the take-home quiz as well as the quiz itself. That is, number 9 is going to be a very similar question to this example or the pencil problem, and the same with the previous questions as well. So there's 9 questions on your take-home quiz and your quiz. Okay, so let me know if you have questions or concerns.